Hello, calculus students, seekers of general truth. Let us continue with yet more complicated examples. So here you have 3x over x squared plus 1, and you can see that the numerator here is a version of the derivative of the denominator with some constant multiplier. So we can use integration by substitution. U is equal to x squared plus 1. Right, du dx is equal to 2x, and now actually I'm going to change things up a little bit. Let's make our substitutions. So this 3 we can pull out to the front, right? That x, that x right there, we're going to leave it alone for the time being. Right. Our numerator here, or sorry, our denominator x squared plus 1, that's just going to change to u. And the part that's left that we ought to consider here is this x and dx, right? So a lot of time what students do when they solve for when they do the integration by substitution, they try to solve for du. But really you want to solve for the pieces that's left over here. So we want to get x dx by itself. So divide both sides by 2, we get 1/2 du, and on this other side we get x dx. Okay, so that means instead of x dx, we can write 1/2 du. So I'm going to write a 1 here, a du here, and then multiply it by 1/2. So this is the equivalent, where all the stuff that I wrote in red here is we're taking out x dx and replacing it with 1/2 du. So just to clean this up a little bit, this is going to be 3/2, the antiderivative of 1 over u du, right, which turns out to be the 3/2, the natural log of the absolute value of u plus a constant. Then in our last step, we substitute everything back. 3/2, the natural log of x squared plus 1. Plus a constant. For the problems with e to the x, I'm going to go through this quite quick because in this course you've probably done many examples of this, but you have x squared here, which is really the antiderivative of x, so naturally that makes it easy for us to say that make our substitution u is equal to x squared. Du dx is equal to 2x. Okay. And then let's start substituting. So I get e, right, the antiderivative of e to the x squared, which is just u. And the part that's left that I want to get rid of is this x and this dx. So that's what I'm going to solve for here. 1/2 du is equal to x dx. So this turns out to be 1/2 du. Right? And so this is 1/2 e to the u plus a constant. But of course, we know that u is equal to x squared. So this is going to be e to the x squared plus a constant. All right, so there you have it. Couple more examples here of using natural log, or the properties of natural log and the exponential function, to find some antiderivatives.